Hello, my dear students. Welcome back to one more lecture on econometrics. In last lecture, we have discussed the dummy variable regression model, in which the dependent variable is in called quantitative form or in ratio scale or interval scale, but the independent variables are in qualitative models or qualitative variable or the nominal scale variable. Okay, so this dummy variable I have told yesterday is basically used for incorporating the effects of qualitative variable in our regression model. Most of the time when we do the real economic analysis or real data analysis, not only the quantitative variable but also the qualitative variable will also affect the dependent variable. Okay, so we need to include these effects of the qualitative variables. So how we can include these effects? As I told you yesterday, or as I told you before, we can construct an artificial variable or called dummy variable that will take the values 0 and 1. Okay, so 1 can be represented for the presence of an attribute and 0 can be represented for the absence of an attribute. Okay, and we are also seeing how we can do dummy variable regression, or how we can find out the parameters such as beta 0 and beta 1 for a simple dummy variable model. Okay, and how we can interpret the result. Okay, so interpreting the dummy variable regression model is not like the general regression model. Here we are having beta 0 and beta 1, and beta 0 is the intercept, okay, and which is the average value of a particular thing for the category in which you have assigned 0. Okay, and this beta 1 is, or the slope coefficient is not the changes in the variable or changes in the values, but it is a differential intercept coefficients. Okay, how does the category for which 1 and 0 assigns are different, that's the slope coefficients are given. Okay, and we have also seen how we can estimate this model manually using Excel. Okay, and how we can do the things, or how we can analyze this data using the data analysis tool pack of the Excel. Okay, so the dummy variable regression model is similar to the earlier regression model. Okay, here also we have a two normal equation, and when we derive this two normal equation, or when we solve this two normal equation for beta 0 and beta 1, we will arrive at two equations, and one equation is sigma yd divided by sigma d square and y bar minus beta cap 1 into d bar. Okay, so up to that we have seen in the previous class, and today I'm going to make a refinement in our model. Okay, what we have learned that W is equal to beta 0 plus beta 1 dummy plus error terms. Okay, we have included only one dummy, but if you look at if you are going for a real economic analysis, or when you are doing a project, or when you are doing a research, you may have more than one independent variables that are qualitative in nature. Okay, so how we can include more than one independent variables that are dummy in nature in a regression model? Okay, so let me take an example. Just the example that we have discussed. Okay, is there is differences in the wage market based on gender as well as caste. Caste is also a qualitative variable, as you know. Okay, and especially in the country like India, the labor market, the lower caste peoples are not getting adequate wage than this, or adequate wage like this upper class people are getting. Okay, so upper class people, they are having privilege, they are privileged group in the labor market, and they are getting more wage than the lower class people. So when we do an analysis on the labor market, especially on wage rate, we have to include the gender as a variable, and caste is also as a variable. Okay, so this is our aim, is there is gender differences as well as the caste differences in the market or in the wage market. Okay, so the gender as well as caste, both are not directly quantifiable, so we have to express the effect of this variable using the dummy variable. Okay, so what I am doing here, I am representing these two dummy as these two variable as a dummy. Okay, so W is equal to beta 0 plus beta 1 d1 plus beta 2 d2 plus u. Earlier we had only one dummy, so we have expressed beta 0 plus beta 1 d. Here we are having two dummies, so W is equal to beta 0 plus beta 1 d1 plus beta 2 d2 plus error terms. Okay, then how we can assign the value 0 and 1 for this differences or this gender dummy as well as this caste dummy? It is up to us, or you can decide to which category I am assigning 0 and to which category I am assigning 1. But remember one thing, you have to remember to which category I am assigning 0, because that is very important in the interpretation point of view. Okay, so here I am assigning d1 is equal to 1 for male and 0 for otherwise, or 0 for females, and d2 is equal to 1 for upper class and 0 for otherwise. Okay, so here we have two dummies. In two dummy we have two different 0. Okay, in first dummy the female is the 0, and second dummy the lower caste is of 0. Okay, so here our benchmark category is 0 as well as 1. Our benchmark category is female as well as lower class people. Okay, yes, so the coefficient attached to this dummy is known as partial differential intercept coefficient. Earlier we have called this top coefficient as differential intercept coefficient, but here it is not the pure differential coefficient but the partial differential coefficient. Why the name partial here? Why I am calling this beta 1 as partial coefficient and this beta 2 as the partial coefficient? Because okay, when I interpret this beta 1, I am assuming that this effect of the second dummy is constant. Okay, and when I interpret the second dummy, I assume that the first dummy is constant. It means that when I interpret that there are gender differences, but when I say such kind of a statement, I am assuming that there is no caste differences. Okay, and when I say about there is caste differences, I have to keep mum about this gender differences. Okay, so I have to say that there is no gender differences. If there is no gender differences, then this would be the amount of the variations in the amount of the variation that the lower class people and upper class people are getting. Okay, and when I interpret the gender dummy, I have to say that keeping the effect of this caste dummy as constant, there is a gender differences. Okay, yes. Okay, so here we have two dummies. Earlier we discussed one dummy. Okay, so in both cases we have only dummy variable as our independent variables. Okay, earlier wage is a function of wage is equal to beta 0 plus beta 1 d plus u. Now wage is equal to beta 0 plus beta 1 d1 plus d2, beta 1 d1 plus beta 2 d2 plus u. Here we are having two dummies. Okay, so a regression model in which all the explanatory variable or all the independent variable are dummies, then it is known as analysis of variance model. Analysis of variance model. Okay, and now we can go now we can check how we can do this analysis or the analysis of dummy variable regression model with two independent variable as dummy using Excel. Okay, so let me take an example. Yeah, this is the example. Okay, I hope that you can see this window now. Look at this labels. Wage, or let me put as a wage, male or female, and I am assigning D1 for male and 0 for female. This is a caste variable, and this D2 is equal to 1 if the caste is 1, sorry, if the caste is upper class, it is 1, then lower class is for 0. Okay, so here look at the first variable. I am just removing this column. Okay, oh, just see that, look at this value 0. I am assigned 0 for lower class and 1 for upper class. Female 0, M for male, for 1 for male. Okay, now let me remove these two columns. Okay, yes. Okay. So here also what you will get separately what will be the average wage of this male, what will be the average wage of this female, what will be the average wage of this upper class and lower class. Okay, and I am not going to do this technique called technique of filtering. Okay, if you do the filtering, then you can manually collect all this information. Okay, so I'm not going for that. I'm just going to the data analysis tool pack, then regression. Okay, then my y range is w. Okay, and in last time we selected only this column. Okay, now I am selecting these two column, both column I am selecting. Okay, now let me put the label is okay. Okay, then let me click OK. Yes, now you look at the coefficients. Yes. Okay, yes, look at here, we are having these are all our coefficients. This is beta 0 and this is beta 1 and this is beta 2. How we can interpret this result? That is very important. Okay, so this beta 0 is the intercept, or it is the average value of your dependent variable for which you have assigned the dummy 0. Okay, but here what we have done, here I am assigned 0, 1 0 for female and 1 0 for lower class. Okay, so what will be this value? This 1313 is the average wage of lower class female. This is the average wage of lower class female. Is it okay? Yes. Then what is this beta 1? This is differences in the wage rate on the basis of gender. Differences in the wage rate on the basis of gender. Okay, so look at the beta. This is the gender coefficient. Okay, and in the gender coefficient, to which category we have assigned 0? Female. Okay, 0 for female. Okay, so this says that male is getting around 350 rupees extra compared to their counterparts. That means there is a gender differences, and when you interpret this result, we are assuming this as constant. Okay, assuming that if there is no cost differences, then this male are getting around 350 rupees extra compared to their counterpart or compared to females. Okay, and what is this? Here 0 is assigned for lower class. Okay, so how we can interpret this result? Compared to the lower class, upper class people are getting around 8790 rupees approximately extra. Okay, so we can say that there is the gender differences as well as cost differences in this market. We are separately analyzing whether there is gender differences and whether there is cost differences. Okay, yes. Now if you want to add more and more variable, you can do that. Okay, yes. So here look at these statistics and look at this p-value. All these p-values are significant and t-values are also significant. Okay, what does it mean? It says that your null hypothesis about the coefficient beta 1 is no gender discrimination. Okay, yes. Then in second, H0 beta 2 is no caste discrimination. Okay, and look at this t value and p value. Okay, this is two values. Yes. Okay, so this p value says that you can reject the null hypothesis at, okay, is equal to 1 minus this. You are 98.6% confidence that you can reject the null hypothesis. Okay, and for this, if you subtract this, okay, you will get 1. It says that you are 100% sure that you can reject this null hypothesis. Okay, so in both cases we assume that there is gender differences as well as cost differences in the labor market. Okay, then look at this f value. What this f value says? Okay, f value says that H0 in f test, but we are assuming that beta 1 is equal to beta 2 is equal to 0. That means there is no gender as well as caste differences. There is no gender as well as caste difference. Okay, so we are simultaneously checking whether these two coefficients are significant simultaneously. Okay, so here the f is what? Here the f is 25.91 and the probability value is very close to 1. So if you subtract 1 minus this, you will get 1. Yes, 99 point something. Okay, so you are 99% confident that you can reject your null hypothesis of your f test. That means both things are, we can reject the null hypothesis that there is no gender discrimination, no gender as well as caste differences. If you reject it, then what does it mean? There is gender differences, there is caste differences, okay, and there is gender as well as caste differences. Okay, so this is the hypothesis testing, and you can also check your R square here. It is 52. What does it mean? It says that 1 minus, okay, using this gender and caste, you are only able to explain 52% of the, or 50%. You take this value, okay, this is good. The adjust R square is good when you take the multiple regression model. So then this is 1 minus, yes, there are 49% of effects, that is this, or there are only 50% or 51% of the variations in wages are explained by this sex variable as well as this caste variable, and 49% changes are explained by some other factors. Okay, so this is all about the multiple dummy variable regression model, in which all independent variables are qualitative variable, or what we call ANOVA models. Okay, so I hope it is clear for you. Okay, now let me discuss some more refinement in this model. Okay, so here what I am going to tell you is, look at this qualitative as well as quantitative independent variables. Now you assume that, okay, so just now we have seen that only 50% of the variations in wages are explained by this two variable dummy, two dummy, gender and caste. It means that there are certain other variables, okay, it also affect the wage, okay, and this may be their education level, their technological level, or their technical efficiency, their experience, okay, or whether they are the union member or not, okay. So all these variables will also affect the wage rate. Okay, so most of the time we will have both qualitative as well as quantitative variable in our regression model. So how we can include both qualitative as well as quantitative variable in our regression model, that's we are going to see in this session. Okay, yes. Now we are going to see between two employees with the same level of experience, is there is any gender differences? Okay, so I am just taking only one dummy now. The dummy is gender, okay, and I am taking a quantitative variable called experience. So what I am assuming that those people, male and female, they are having the same experience, still there is a gender differences. If we want to see such kind of a result, I have to use a model called ANCOVA model, analysis of covariance model. Okay, so analysis of covariance model or ANCOVA model is a regression model in which there are qualitative as well as quantitative independent or explanatory variable in a regression model. Okay, yes. So I am specifying this as wage, or y is equal to beta 0, beta 1 d and beta 2 x plus u. Okay, that means wage is a function of gender as well as experience. Okay, so what will be the expected wage rate when your dummy is equal to 0 and experience is there? it will be beta 0 plus beta 1 into 0. So beta 1 0 will be cut off from will be out of from there. So there will be only beta 0 and beta 2 x, because the experience is applicable to both gender category. Okay, and if expected value of y when d is equal to 1, it is beta 0 plus beta 1 dummy plus beta 2 x. Okay, so this beta 0 will give you the average wages of female for a particular level of experience. Okay, and this d is equal to 1 will give you the average wage of those people, or average wage of males with a particular level of experience. Okay, and in this model we are assuming that both gender, male and females, only the average value will be different. Okay, but their slope coefficient will become the same. That means this is the slope of the regression line, this is also the slope of the regression line, and this slope is for male and this slope for female. You can see that the slope is becoming the same. It means that whenever there is a changes in the experience, okay, this regression model, whenever there is a change in the experience, both the salary of male and female will increase in a similar model, in a similar fashion, or similar magnitude. Okay, only the average salary will change. Okay, this is the salary of the female and this is the salary of the male. Okay, and this is the salary of the differences in the male and female. Okay, but we are assuming that the slope of this line, or the slope of the regression line, will be the same. I will show you that. Okay, yes. So let me take an example of this. Yeah, let me take an example. Okay. Yeah. Okay. Yeah. Yes. Now you see, there is wage rate. It is around 1345. Okay, and this fellow is female and she is having only 2 years of experience, and the second fellow is getting around 2435 rupees as the wage, and that fellow is a male and his experience is very high, it is 18 years. Okay, so I am having both experience and gender dummies. I am having experience and gender dummy. Okay, then what I am going to see? I am going to see is there is a gender differences considering the experiences. Okay, so what I have to do, go to data, analysis, regression, give your dependent variables, okay, and give your sorry for that. Okay, regression, this is the yes, and this is the, we are selecting both gender as well as experience. Okay, then label is there, click OK. Yes, now you see what is happening here. Yes. What is happening here? This is beta 0 is equal to beta 1 and beta 2. Okay. So these are all the coefficients. How we can interpret this? Beta 0. Beta 0 means what? It is intercept or it is a benchmark. It tells us what is the average wage rate of those people whose wage rate is equal to 0. Sorry, whose average wages, those people who are assigned 0. Okay, that is female. So this is the average wages of female, beta 0. Okay, then what is beta 1? It is the differences in the average wage rate between 1 and 0, between male and 0. Okay, so it tells us that how the one category or how the male category is getting, whether they are getting an extra amount of wage rate compared to their counterpart. Okay, so this is the differences in wage between male and female. Okay, so look at the differences is around 525. Okay, so what will be the average wages of the male? This will be this beta 0 plus beta 1, 1891.9. Okay, so this will be the average wages of the male. This is the average wage of the female. Okay, and if you subtract this from this, you will get 525. This is the extra wage rate, the average extra wage rate that the males are getting than the females. Okay, then what is beta 2? It is experience. It tells us that on an average, if a person is having additional 1 year of experience, irrespective of their gender category, they are getting around 19 rupees extra. So for both male and female, if their experience increased by 1 year, they are getting around 19 rupees as additional. Okay, so for every year they are getting an average incremental rate of 20 rupees per annum, and this is irrespective of the gender, whether we are not considering whether they are male or female, all of them are getting around 20 rupees per annum. Okay, and now we can check whether these variables are significant or not. For that, what we have to look at this t-stat. Yes. Okay, and this is, look at this t-stat. Okay, this is 1 minus this one. How much you are getting? Okay, this 1. What does it mean? 1% you are sure about. Sorry, 1 we are not considering. Second one. Okay, 99% you are sure that you can reject the null hypothesis of no gender discriminations. Here, what is the null hypothesis? Okay, here it says that the experiences are so the beta 2 coefficient is equal to 0. That means the people, they are not getting additional amount of wage whenever their wages increases. Sorry, whenever their experience increases. Okay, that's also rejected at 84. Yeah, that's 84%. Okay, so here we can only say at 84% significant level, and if you 1 minus this Yeah, it is around 15%. We are not confident about it. Okay, so here this coefficient, B experience coefficient, we cannot interpret because this experience coefficient is not that much significant. It is significant only 84%. Okay, so 15% we have to we have doubt about its significance. The type 1 error is about 15%. Okay, so this is the dummy variable model including both qualitative as well as quantitative variable. Is it okay? Yeah. Now, yes. Suppose till now we have given 1 for male and 0 for female. Okay. Now assume that if we had given 1 for female and 0 for male, how the things got changed, how the interpretation will be changed, or how the result will be changed. If there is any changes in the result, surely there will be some changes in the result. Okay, but in the final result or in the final interpretation, there will be no any changes. Okay, so whatever we have said about female, now you have to say about males, because we are comparing the things with the category for which the 0 is assigned. So if we have given this kind of a assignment, then we have to interpret the things on the basis of male. Okay, so till now we have interpreted the things on the basis of females, or we have compared the things with the female, and now onwards you have to compare the things with males. That's only the differences. Okay, now one more problem associated with this. Okay, here look at this. For gender there are 2 categories, male and female, and assume that we have defined 2 dummy variables to indicate 2 categories of this dummy. We know that for the gender there are 2 categories, male and female. And what will happen if we have assigned 2 dummy to represent 2 categories? Okay, I'll show you that first. Look at this. Okay, can you see this data? I hope it's so. Look at here, wages, what I am given is, for male I am giving 1, for female I am giving 0. Okay, so all these fellows are male. Okay, and these fellows are female. Okay, so what I have done, I have given 1 for female and 0 for, so 1 for male and 0 for females. Okay, or I have assigned 2 dummies for 2 categories. Now assume that you run a regression. Go to data, analysis, regression. This is for this one. Okay, and for this you click this one. Okay, yes, yeah. What is happening here? You look at this value. We are not getting the values. We are not getting the values for the first dummy. Okay, and look at here for the second, we are getting the values, but we are not getting these p values. We are not getting the p-values. So what kind of problem that we have encountered here? Is there is a problem? We have one qualitative variable called gender. For this gender, there are two categories, male and female. For differentiating male and female, we had given one dummy earlier. During that time, there was no any problem. But when I assign two dummies for representing two categories, we are not getting the result. Okay, so this is what we called dummy variable trap. Dummy variable trap. Okay, so if we have two categories, then we should not introduce two dummies. Always introduce one less dummy. Suppose if the category is having if a dummy is having 5 categories, you can introduce 4 dummy. Okay, if a dummy is having 3 categories, you can only introduce 3 minus 1, that is 2 categories, 2 dummies. Okay, otherwise we will fall into what is called dummy variable trap. Okay, so this dummy variable trap is basically due to the linear independent of this male and female, because whenever there is 1, there is 0. Whenever there is 0, there is 1. So you find out a correlation between this is equal to correlation between these two. How you are getting, what you are getting here, look at this value. How much it is? You're getting negative 1. If a correlation is negative 1, what does it mean? There is perfect correlations. Okay, you remember the assumptions of Euler's. Last assumption of Euler's, no multicollinearity. That means in a multiplication model, 2 or more independent should not be linearly correlated. Okay, that assumption is violated here, and because of this thing, we are not getting the Euler's result. Okay, so what is the remedial measure for these things? The remedial measure is 2 things. Okay, first one is if a dummy called gender, okay, male, female and transgender. How many categories are there? There are 3 categories. Okay, then how many dummy you introduce? You can only introduce 3 minus 1 dummy or 3 minus 1 2 dummies. Okay, then if there are 4 categories for a dummy, introduce 3. 2, introduce 1. Okay, then there will be no issues. Or what you can do is, you can assign, if there are 3 dummies, you can assign 3, 4 you can assign 4, 2 you can assign 2, no problem, but you have to remove the intercept. Okay, it means that you should not include the intercept in your economic model or econometric model. That means you should run an interceptless model or regression through origin. Okay, how we can run it? Let me check it. Okay, now you do the same things: data analysis, regression. Okay, we have selected everything, and now you look at here. There is an option called constant is 0. What we are doing here? We are suppressing the intercept. We are assuming that the intercept is equal to 0. Okay, now you run the regression. Okay, now you are getting the average wage for female and male. Okay, what does it mean? Females are getting around this much salary, or 1622, and females are getting this much salaries. Here the females are getting around 372 rupees extra compared to males. Okay, so in this problem, females are getting more wages, right, than the males. Okay, so here the beta 0 and beta 1 both will give you the average wage for the category in which 1 and 0 assigned. Okay, so and this problem is called dummy variable trap. Okay, dummy variable trap, and this trap is occurring because if at any point of time, any observation, if you add d1 plus d2, it is always end up with 1. Okay, so this problem is called a dummy variable trap. How we can remove it? Two options. If for a category, if there are if for a dummy variable there are m categories, introduce only m minus 1 dummy, or you introduce as much as dummy, but you should not include the intercept. Okay, you should not include the intercept. Okay, now we can include as much as dummy variable we want to do, or we want to include. Okay, look at here, I am assigning here 5 dummies. 5 dummies. Okay, in this d1 is for sex variable, it is male 1 and 0 otherwise. d2 1 if ages is below 25, 0 otherwise. If ages between 25 and 50, 0 otherwise. So you here we are having 2 dummy for age. What does it mean? It means that there will be 3 categories. Okay, the category will be below 25, 25 to 50, and more than 50. Okay, so for this we are introducing only 2 dummies, and d4 1 if high school education, 0 for otherwise, and d5 1 is higher secondary education degree and above, and 0 otherwise. Okay, so you can include as much as dummy you want to include, no problem. Okay, so in this problem, what will be the intercept will give you, or what the value this intercept will give, or what will be the, how you will interpret the value for this base group, or what will be the base group. Base groups are those group or those category in which 0 is assigned. Okay, so here 0 is assigned for female, okay, less than or more than 25, okay, then more than 50, okay, then those who doesn't have high school educations, and those who have not completed higher secondary degree and above education level. Okay, so this base group will define or will give you the salary or the wage rate of the female who are above 50 years and having below high school educations. Okay, so in such manner you can define as much as dummy variable you want to add. Okay, yes. Yes, so all this thing I have given you in the slide, and if you are interested then you can read it. Okay, so thank you for watching this video, and in the next video I will discuss some concept or some uses of this regression or this dummy variable regression model. Okay, so kindly do watch the video, and if you have any doubts you can personally message me. Thank you.